Hello, good morning, good afternoon, everyone, and welcome to today's webinar, Uncover Financial Fraud with Amazon Neptune and Tom Sawyer Perspective. Thank you for taking time out and being here today. My name is Michele Arpaia. I am a go-to-market strategist working at AWS, and today with me we have Janet Six. The agenda for today. We will touch fundamentally on three things. The core part of this webinar is fraud detection. We want to show you how to tackle this issue, this situation, this specific use case using graph database and using Tom Sawyer platform, which is powered by database AWS Neptune. If I may ask to put your microphone on mute, please. There's a bit of echo. All right. So feel free to ask questions as we go along. The chat is monitored. We will answer those in the context, or we can have a bit of a time at the end of the webinar to answer some further questions. Okay, let's get started with the graph database first, which is the building block of the solution I'm going to show you today. First off, graph is a hot trend. Indeed, the graph database have been growing steadily since 2014, as it is illustrated in this chart. The chart, maybe for some of you are familiar with DB Engines. DB Engines is a catalog of databases, and they rank the databases according to their popularity. There are a few reasons behind this growth and this popularity is especially the popularity of, which is an anticipation for growth for graph databases. Major enterprises, and I see this in the field as well, are actually studying connected the data. It's not just gathering data and pulling in lots of data to get inside of it, but a lot of scenarios have an intrinsic graphic nature, meaning there is an interconnectedness of data that is really revealing of hidden patterns. And this is paving the way to proof of concept and experimenting in the field. And of course, this is increasing the popularity and feeding the popularity across the board. But why? I mean, the question is why? What's the deal? Why they are so interesting? Deep down, graph databases rely on a rock-solid foundation name called graph theory, and it's a very simple concept. It's just a bunch of dots connected by lines. That's it. So, depending on which lingo you are familiar with, dots are called vertices or nodes, or lines are called edges, relationships, but fundamentally a graph model is just that. However, what's interesting is that when you start connecting the data through this pattern, you will see that a huge network will come out. Excuse me, I forgot to lock the door. And that's really interesting. This intrinsic property of graph is to, when you start connecting the data, you will see things that if you look at the data points alone are not visible. And fraud detection is one of those cases. If you look at this network on the left side, it is a subset of a network of customers of company. They have pulled together raw data and start seeing the data that they had stored somewhere. And then when you are looking at all this data from this perspective, there are a few interesting properties. First of all, you start looking at the structure of the network. And you see here there are hubs, there are hedges, there are clusters of customers, there are some density property, there are properties like centrality, and you see which customers are more interconnected. And this, at the first glance, already can give you a lot of information about the actual data that would not be visible. But if you, in this specific case for fraud detection, if you know that some clients, for instance, they are involved in some complex fraud structure, If you look at the data of customers individually, as I said before, you will not be able to see the fraudsters. They would appear just like legitimate people. Working on connections between users instead can show you a lot more information. Features like, actually, let me give you an example. If you take three, four, five people in this network, you will see that there are some properties attached to those people, like email address, phone numbers, etc. These specific data point are not an indication of whether or not the account behind that phone number is fraudulent or not. But when you see in the context connected, the value of, and you see that, for instance, three individuals have the same phone numbers and they are connected to other individuals with the same email addresses, probably something unusual is going on, right? So something suspicious. And what you want to get to, and this is really what we are going to show you today, you want to land from your data, your structure, your connected data to a point where you can separate out legitimate people from the fraudsters in an easy and efficient way. And this is what we are going to discuss today. However, before we step into that in this solution that we have developed with the Tom Sawyer, um, I just want to broaden the scope. I mean, graph database is not just fraud detection. I'm sorry to state it obvious. There are numbers over the years, over the last decade, actually, there have been a number of use cases being consolidated and very much. I'm personally involved, for instance, in recently in a project for social networking for a big enterprise. They have noticed that the people, a lot of people in the organization are a bit disconnected from the value of the company, from the culture, and a lot of messages that is not cascade down properly. And the management thinks one thing, and the people in the field think something different. And we are doing a social network analysis there. So we are getting the data, seeing how people are interconnecting, identify the hubs where people, where the information sits, and to channel the right information throughout the organization through those big influential hubs. And this is a typical use case, but I've started to noticing those use cases also inside the organization, which is interesting. Recommendation engines as well. So another field very much consolidated. It's not that product recommendation were not possible before, but there is a nice twist, especially when you have a graph database and machine learning combined, you can have a more accurate product recommendation, and so on and so forth. So there are families of use cases, very specific, very clear cut to when to use graph databases. Graph database is not a one size fits all. It's not for everything. There is a bit of thinking of a concept to understand before you jump into a project like graph databases. Despite of what most of people may say, use graph for everything. Graph is a very peculiar graph databases are very peculiar for and very fitting for a great number of use cases, but still, very identifiable. It's not a generic solution. At AWS, we have not just an AWS Neptune. AWS Neptune is part of a broader portfolio of databases, the one that you see in the middle. And we are driven by a very simple, let me say, philosophy, which we call the purpose-built databases. Basically, the idea is to provide a specific database for a specific set of use cases. We do not believe in one-size-fits-all approach. In fact, a one-size-fits-all doesn't fit anything. We believe that modern applications are very segregated, very complex, very articulated, and they need to be served by different kind of data model and data access patterns. And that's why we have developed such a broad category of databases, stemming from traditional relational databases to QLDB, it's a ledger, centralized ledger, and GraphDB, and time series, etc., etc. Specifically, the solution, the AWS graph database solution is called Neptune, Amazon Neptune. it is a platform, it is an engine, it is a managed database. It means that it is a cloud native database managed by the cloud, by AWS Cloud, which basically means that a lot of traditional tasks like patching, backup, restore are managed by the platform. So what you have to focus on is on designing the right data model for your database and optimizing the queries. And this is the value add that all people around database should be focused on. Everything else is what we call undifferentiated tasks that can be easily put on autopilot with a control, of course, but we're not spending a lot of money and time on that. And that is what Neptune does. And Neptune is also compatible, actually integrates with the two interesting APIs models. That are property graph and RDF, resource description framework. This is important, right? Because when you analyze any piece of technology, and specifically for database, you have always ask this question is, how data is represented and how do I access the data? There are two primary graph models that are widely used. A property graph, the one you see on top, and a resource description, as you see below. A property graph is probably the typical graph that you are familiar with, the dot, the nodes, the edges, and properties on those properties. So it's, in a way, many people indicated this as a graph database. A property graph database is a data and a metadata in one place, which is, I think, very good representation of what a property graph database is. The leading property graph API is the open standard Apache Tinkerpop, and Gremlin is probably the most famous language in that space, and that allows you to traverse the network very easily. It has a little bit of learning curve at the beginning, but once you master that, it can do a lot of magic. The other one is OpenCipher. It's another, we see that a lot of developers are in love with OpenCipher as well. It's an open source declarative query language for graph. And it's interesting because it provides a very familiar SQL-like structure to compose queries for graph data. The second is RDF. This is the semantic web. It is an alternative way to represent your data model. It's more around ontologies, big names, big word, but it's another way. It's a way to represent concepts, and with a triple typically, which is the subject, predicate, and object. It has its own language, which is much more standardized than Gremlin and OpenCipher. It's called Sparkle, and is supported by the semantic web, the W3C. And we see, and this is the interesting bit about AWS Neptune, Amazon Neptune, we support both of them. Both models are into the Neptune engine. Another thing, there are a lot today. It's not a deep dive on the Neptune, of course. There are other webinars, and I will put in the chat a few links if you're interested. So I'm not going to illustrate all the features. We are focused on fraud detection today. However, there are two interesting features I want to highlight, and are very interesting and fitting the context we are discussing today. One is integration with machine learning. So you have a lot of data. We see the graph database, billions of nodes, interconnected data sets, but oftentimes it's very hard to extract data using queries based on human intuition alone. For instance, I showed you before that big network of fraud detection. It's humanly impossible to start looking at it and then extract some hidden correlations. And you do this with machine learning. Machine learning is very interesting, very, very fitting to that particular purpose. And you can train with the machine learning to detect patterns within a graph data. There are various ways to do that. If you're interested, just put on the chat. I will give you some link, and we can even organize another webinar specific on this specific integration, which is actually a very common combo. I come across this 80% of our time of use cases that I come across with customers, machine learning is always an element of the story, of the architecture, sorry. The other interesting feature is the intelligent, what we call the intelligent search. You may be familiar with the concept of Elasticsearch. We call this open search as well. Basically, it's a piece of technology that indexes your data according to what you want to optimize in terms of searching. And then the Neptune becomes the source for that search, and that search can be used by application, for instance, to find very efficiently according to some dimensions that you can define through Elasticsearch. And these are two native services on AWS, Amazon Neptune, and Amazon Elasticsearch, and they integrate very easily. And you do this integration also through what we call Neptune Streams, which is another interesting feature that gives you the possibility, especially in an event-driven architecture, to detect all the changes happening in the graph and put them in a sort of sequential log that with this log you can feed an application, or you can feed and keep the index in the Elasticsearch updated, etc., etc. So this is another very practical, very common integration we see all the time. Right, so I think we can jump now into the key question that we want to address today with Tom Sawyer. And basically, is okay, we have the data, we have Neptune, we have this interesting building block, we have the data in Neptune. I want to start visualizing the data, and I want to start discovering what data looks like, smells like, and I want to run some algorithms, in this case, to detect fraudsters. Janet, over to you.
Thank you, Michele.
I stopped sharing. Yeah, you can take over.
Okay, thank you.
You're welcome.
So at Tom Sawyer Software, graphs are what we do. We've been in this field since 1992, and we specialize in creating graph visualizations and doing analysis for very difficult problems in big data. Our offices are worldwide, and our headquarters are in Berkeley, California. We have a large set of customers across many different fields, including data, automotive, aerospace, governmental agencies, healthcare, financial services, and logistics. And specifically for fraud detection, we help customers with visualization and link analysis so that they can manage risk, combat fraud, and also to grow profitable customer relationships and comply with government regulations. There are some specific advantages of graphs. For example, we can identify patterns of behavior, and those kind of patterns can be found both visually through the visualization, but they also can be found in a data-driven way through analytics. Graphs are also useful to reduce false positives and provide context to machine learning. Some of the industries that are served with fraud detection include banking, credit services, public safety, and policing. Tom Sawyer Perspectives is our flagship product. It is a low-code graph visualization and analysis development platform. And our customers use this platform to create applications that help them to discover insights in their data. And so how is this done? First, we connect to the enterprise data sources, in this case with Amazon Neptune. And then we process that data. And we do that with a combination of expressions and rules and filters. The filters can be interactive and placed there by the user, or they could be created automatically given some analytics that we run on the data. And once we have done that, then we can create interactive views that show the visualizations of parts of the data and also to drive analytics on the data. Perspectives has a specialized integration with Amazon Neptune. It is optimized for both reading and writing, and it includes a customized schema extraction, which aids rapid application development. It also is able to consume streams and employ Lambda functions. And altogether, this helps customers to rapidly build and preview analysis and visualization applications. And those applications can be deployed to EC2 containers and scaled with Elastic Container Service, Elastic Kubernetes Service, and Fargate. We can use Tom Sawyer Perspectives to create scalable fraud detection applications. And so let's take a look at what that might look like. We can create an application that allows data scientists to interactively explore the data in Neptune. And also, we can have analytics that are running in the background and they're automated that are looking for fraud. And in fact, we can use both of those at the same time in our application. And once we have those, we can act. We can use process-driven dashboards and workflows to help disrupt the fraud. So let's take a closer look here. When we're trying to disrupt fraud, first, we analyze. We have analytic processes running constantly on the incoming data, and they generate alerts of potential fraud. Those alerts are prioritized and they're presented to the user in this dashboard environment. And the user is then able to focus using a rich set of graph-based visualizations to understand the alert and either validate it or dismiss it. And then they can act. Analysts can add annotations and other information to the graph, and they can also initiate additional procedures such as opening a case or initiating some other type of activity that will disrupt the fraud. So with Perspectives, which again is a platform to build graph visualization and analysis applications, we have built an example fraud detection application that is connected to Amazon Neptune. This is a sample source with manufactured data. And also you'll see that we obfuscated the data as well. But of course, we would be working with your data and we can customize it to show what you need to show and also have the behavior that you need. So our example application here integrates with Amazon Neptune. We have visualization and analysis views. And it has two modules, the Alerts module and the Explorer module. The Alerts module works with the background analytics that we have previously mentioned. And these analytics use specialized Gremlin queries that go to Amazon Neptune and find potential fraud rings. And once we have those, we can explore and analyze whether or not the fraud ring is a real one or if we can dismiss the alert. We'll look at this further in a moment. Then we have the Explorer module, and this is intended for investigators who are suspicious of certain accounts or transactions or businesses, and they want to do their own investigation based on their findings. And so in the Explorer module, they can enter their own queries and then explore from there. So now we're going to take a closer look at each one of these modules. I have a couple of recordings here of the each module, and so we're going to talk about what we see here in those. So again, we are here in the alerts module. We have Gremlin queries that are running in the background, and they're finding potential fraud rings, which you see here on the left side. We are seeing accounts that share features, like they share the same phone number, same physical address, same email, same IP address. And we're going to go and we're going to investigate one of those. We have 7 accounts here that are sharing 2 features. So let's open and see what we find. So we are looking at the data from Amazon Neptune here, and we also are pulling up this this view here in the middle that tells us which potential accounts are involved in this potential fraud ring, and the features that are shared. So we see here that we have 7 accounts and 2 phone numbers. We're going to add swim lanes to this visualization so we can very quickly see the accounts and which phone numbers that they're using. So we see here that there is one account that is associated with 2 phone numbers, and those phone numbers are being shared with other accounts as well. So we think this is suspicious. So we'll select it, and we're going to load the neighbors so we can find out more. So again, we keep the swim lanes in this visualization so we can very quickly categorize the information that we're seeing from Amazon Neptune, the accounts, the transactions, the phone numbers, and so on. Now let's take a closer look and see which transactions are associated with this account that we're suspicious of. So we can very quickly see that there's a few $1,000s worth of transactions here. In fact, it's $9,000 worth of transactions. So that's suspicious. We're going to investigate further. So we're going to select these transactions, and we're going to load more neighbors from Amazon Neptune. And now we can very quickly see which businesses were involved in these transactions. So we see quite a bit of suspicious activity here. So we're going to come back to that account, and we're going to select it, and we're going to mark it as fraudulent. So we're making an annotation in the data here. Now, due to our investigations, we see that there may be more fraud going on, and maybe there's connection to other fraud rings. And so we want to know more about what's going on in this area of the data. So we've gone back to Amazon Neptune and we said, give us more information, give us more data that's related to this account that we believe is fraudulent. And so now we're able to look out one level, and we can see many potential fraud rings here and the interconnections between them. We can use several styles of layouts in order to visualize these results in several different ways. Different layouts are useful for different parts of the fraud detection application, and those are all available to you as you're using the application. So we're going to use a circular view here. We're very much able to see the clusters in the data, and we can very quickly see the groupings of activity together and the relationships between them. And we're going to zoom into this particular part of the connection between the different fraud rings here, and you're able to very quickly see which accounts are involved, which transactions, and IP addresses. So we may have several fraud rings interrelating with each other at this point. Okay, and so that is the alerts module that we built in our example fraud detection application. Okay, so now we're going to take a look at the other module, the Explorer module. And so this is the one that investigators use when they have a suspicion for a special account or business or transactions, and they can enter a query on their own. So we see here, we give some example queries an investigator could use, but they're also able to open and use their own specific query, which is what we're going to do today, because we are suspicious about activity happening with a certain business. So we enter a query for that. We ask Amazon Neptune, send us that data. And you see here that we have a business, that particular business, and their recent transactions. We want to explore further one of these transactions, the $994 one. So I'm going to select it, right-click, and hit Load Neighbors. And now we're able to see which account was involved and which IP address was used for that transaction. So we're suspicious due to our investigation. So we want to know more information here. What else has been going on at this IP address? So we're going to load those neighbors. And now we can very quickly see all the recent transactions that have happened from that IP address. We're going to apply a circular layout. We can very quickly see the clusters of activity, the transactions, the accounts, and the business. And now we're going to apply a different kind of view because we want to understand when these transactions occurred and how quickly they occurred. So we see there at the top level, the IP address. And then the next level, we see the transactions. We're going to add a table view. And now we can see the same information, both visually in the graph and also here in the table view, which transactions, which accounts were involved, and the timeline here. The timeline shows us when exactly these transactions occurred. And we can mouse over each transaction. We can see some information about that. And we can click on it and say, take me to that transaction. Show me where this transaction has occurred. So due to our investigations, we are suspicious of some particular transactions. So we're going to select those. We're suspicious of this one. So we're going to select that from the table. And we're going to load neighbors directly into the visualization. And there's another one our investigation showed us was interesting. So we're going to select that as well. Load those neighbors. We're perusing these transactions. The information that you see here in the table, by the way, is customizable for each application that is created with Perspectives. So we've loaded neighbors for this transaction as well. So let's take a closer look at that data that we just got from Amazon Neptune. So we see here that this transaction was with an aviation business, and so was this one, and so was this one, and one more. And so we may, through our investigation, have discovered a fraud ring that is targeting the aviation industry. Okay, so this was an example application that was built with Tom Sawyer Perspectives. The application that you can build on your own or with the help of our solutions department would be customized for you and for your data. It can have the views that you need, it can have table views where you need, it have charting where you need, but it is specific and customized to your particular application and to the structure of your data. So this was just the beginning of what you can make with Perspectives. And so I wanted to give an example of how the example application we just looked at could be extended. So one thing that could be added to an application like that is looking for bots and discovering that type of activity. And so let's take it for example here. So we see at the top level here a particular IP address. And at the next level, we see the transactions that are associated with that IP address recently. Now, let's say that our analytics tell us that these few $1,000s of transactions have all happened from this one IP address in 2 minutes. And so, of course, that is an unusual activity to have that much worth of transaction happening that quickly. And so that could be a pattern that indicates that there's fraud happening through a bot. And so we're able to capture that pattern. And then we're also able to visualize that. So investigators can look further and they can very quickly add what we see here in the next level, which is the accounts and the businesses which are affected and involved. So in addition to the best-in-class visualizations that help people see fraud and understand what's happening with these very high precision visualizations and these very interactive and customized visualizations, it is also important to use those in conjunction with analytics. The analytics are data driven, and they go and find interesting parts of the data so that we have direction on where to look in the data for those insights that we're trying to find. Perspectives comes with 30 built-in analytics of several different types, as you can see here. We also can create custom algorithms for you that are tailored for your application. We have been in the graph field since '92, and we have several staff members that have been in the graph field for decades. So a little bit more about Tom Sawyer and AWS. And how would you use an application like the one that we just showed? Well, first of all, if you want to use a ready-to-use application, you can go to AWS and you can use the Tom Sawyer Graph Database Browser, which is a ready-to-use application that you can point at your graph database, and you can see those high-precision visualizations, and you can also apply analytics to the data. And we also have the Tom Sawyer Perspectives deployment container. And what that is that once you have created your Perspectives application, you can use the deployment container in order to scale your application up and down per your usage on AWS. So thanks for joining us today. We're very glad that you're here. And if you have any questions, please contact us at Tom Sawyer and AWS.